In this video, we're going to go over key features of quadratic functions. The domain of a function is all input values that satisfy the function without restriction. Typically, the domain is all real numbers. However, in the case of an application problem, one must determine the most reasonable input values that satisfy the given situation. When a quadratic function does not have a specific interval and is not an application of real-world situation, its domain is all real numbers. So if you were to answer it, you could write all real as your domain. This is expressed by showing that the input values exist from negative infinity to positive infinity. So these are the two options you'll be able to pick from for your domain. Just so you know, to help you remember, if it is all real, one way to help remember is if there are arrows on your graphs that are saying that it's going to continue outwards, that means I can plug in any x and all my x's would continue to be true. This will be negative infinity to positive infinity. Arrows go on for infinite amount of time. So if you see the arrows, think infinity. In this example, find the domain of the quadratic function given this equation. So if you think about it, domain means we're looking at the x values, the input. Can I plug in a 1? Yes. Could I plug in a 2? Yes. 3? Yes. I could plug in 4. I could keep plugging in all these numbers, which means I can plug in all the way to positive infinity. What about the left direction? What if I plug in a 0? Negative 1, negative 2, negative 3. I could keep plugging those in. So to represent that I can plug in any number for my domain, I say negative infinity to positive infinity, or all real numbers. You may pick, you don't have to put both. Find the domain of the quadratic function given the graph. I look at the graph, automatically something sticks out to me. I see that there are arrows on the left. Left direction is the negative infinity. And I have an arrow on the right, which is the positive infinity side. So my domain for the x values would be negative infinity to positive infinity. If the range comes up, if you remember, range means that we're looking at the y values. My y values, that's as high as my graph goes. The highest it goes is y is a 0, and the y's go down, 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 so I'd be all the way down at negative infinity. So my range would be from negative infinity all the way until it hits at that 0, and my range would stop. Or you could say that y is less than 0, less than or equal to 0, because it hits the 0. I prefer the interval. It's a little bit easier. In this example, we are given in a real-world context. Amit is a diver on the swim team. Today he's participating by jumping off a 14-foot platform into the pool. Amit's height in feet above the water is modeled by this function, where x is the time in seconds after he leaves the platform. About how long will it take Amit to reach the water? Describe the domain of this function. I'm going to use vertex form to graph this. So I'm going to take out a 0, and the 14 stays positive. It's going to look a little sketchy, but we're just going to try. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's the diving board. He dives, and it goes down 16, down 48, 16's 14 is already getting B. He hit the water before he even gets to 1 second. So he dives, he hits the water, and then 1 second's way down here. So for the domain, for this word problem, all we're really thinking about is how long he's diving for. So he's diving from 0 until he hits before 1. So I'm just going to say 1. So the domain would be 0 to 1 for this word problem, or the real world context applying to it. This function, if they just gave you this equation and asked, it would be negative infinity to infinity. But because it's the word problem, you have to think about which one would work best. Sometimes they'll ask you about money, or they'll have real world context problems with money. And they'll give you a function, and let's say it goes like this. When you deal with money, it usually will say a positive amount. So when you look at the graph, the x's that give you a positive amount would be between 2 and 4. So you would say between 2 and 4 is the best domain to get the most income. So it's just sectioning it off. The key features that you're going to be labeling today will be the x-intercepts, which are when it touches the x-axis, and you will label the point x, 0. The y are when it touches the, it's not going to show up. Let's try this one. The y-axis, which would be 0, y. We write them as points. Then we have a minimum or a maximum. You'll just be able to look at if it's the lowest point or the highest point. The axis of symmetry is down the middle and is written as x equals some number, whatever that number is that it crosses through. And where the function is increasing, so where it's going up, and where the function is decreasing, so where it's going down. I am given the graph. Lucky you guys, you don't have to graph it. It is given to you. The x-intercepts, -2, 0, +2, 0. Notice I write them as points. My y-intercept, where it crosses the y-axis, is at -4. Oh, sorry, 0. Y is -4. Our vertex is 0 down 4. It's that point where it changes direction. Maximum or minimum. This is a minimum. And the axis of symmetry, I'm just going to cut it right down the middle, which means x is equal to the number on the x-axis it hits is a 0. And that example is done. Next, we're going to do increasing and decreasing. Increasing is when the graph is going up. Decreasing is when it's going down. I'm going to go straight to example 2. You can read through the steps if you'd like. As I draw my graph from left to right, just like reading a book, you'll notice from here, as I draw, my pen is going down until it hits right here in that middle piece. This is the decreasing. Then from here up, it starts to increase because it's going up as I continue drawing my graph. To label the increasing side, I start at this line right here, that axis of symmetry is the number 0 to positive infinity on the right. If I do the decreasing side, on the left there's an arrow, so I put negative infinity for the left. And then as it goes, it stops at the 0. Notice how they're in the same spots. Sometimes I like to fill in the infinities. So then you can just drop those values down and create that interval. So if I wanted the increasing, I would take those two values, that 0 and positive, drop them down in that same order, and put them in parentheses. We are going to skip this section. It will be next time. And we're going to go to 3 and try increasing and decreasing again. I put my pen on the left, and as I draw it, it is decreasing. Until it hits that 0. Then it begins to increase. So my decreasing section would be negative infinity to 0. Increasing would be the 0 to infinity. Example 4. Vertex 0, positive 4. Axis of symmetry is that line that cuts it right down the middle, and it hits the x-axis at 0. X-intercepts negative 2, 0, positive 2, 0. Y-intercept is 0, up 4. It is a maximum, and the domain of the function, see those arrows? If you remember, the domain when there are arrows is negative infinity to positive, or all real. The range would be, as I scroll and look at the y values, it would be negative infinity, and then it stops at the number there. It stops at 4. When is the function increasing? I put my pen on the left. As I draw it, it increases until it hits here, where x is that 0 in the middle. then this piece would be decreasing. Positive infinities on the right, negative on the left. Increasing is from negative infinity to 0. Decreasing is 0 to infinity. On example 5, my vertex is positive 1 down 4. Axis of symmetry, I look for that line that cuts it right down the middle. And it hits at the x value of 1. My x-intercepts are at negative 1 and positive 3. My y-intercept is at 0 down 3. It is a minimum. The domain, I know I have arrows on both sides, negative infinity to infinity, or all real. The range, the y's, so as I scroll up, I'm not hitting the graph, I hit the graph at negative 4, and then the graph continues to go up and up and up and up and up, so that'd be positive infinity for the range. Increasing and decreasing, I start on the left of my graph and draw. It's going down until it hits that line of symmetry. Decreasing, then it starts to go back up. Positive infinity on the right, negative on the left, and this number that it hits at on that middle line is the number 1. So my decreasing is negative infinity to 1, and my increasing is 1 to infinity. I'm going to do a few more examples that are not on the notes in case you were struggling. So extra examples for increasing and decreasing. As I start on the left, that section is decreasing. This section is increasing. Infinity on the right, negative on the left, and I look for that middle number that it hits. This number it hits on my graph would be the number 2 for x, 1, 2. So increasing is from 2 to infinity. Decreasing is negative infinity until it hits the 2. Increasing hits at the number negative 1 this time to infinity. Decreasing is on this side because it's going down. So it goes from negative infinity until negative 1. Negative infinity, increasing until it hits negative 2. Decreasing. So decreasing would be the negative 2 to negative infinity section. Increasing would be negative infinity on the left, negative 2 on the right. increasing until it hits the number 1. Decreasing from 1 to positive infinity. Domain and range extra examples. Domain has the arrows, negative infinity to infinity. The range would be from -1 all the way to positive infinity, because it's going all the way up for the y values. Y values go up and down. Domain arrows, negative infinity to infinity. These ones are nice. The range is the hard one. 1, 2, -2 until it hits positive infinity. Domain arrows, negative infinity to infinity. The range would be from, that's a +2, and this is a it's going down, negative infinity. So negative infinity is first. It always will be on the left until it hits the number 2, and then it stops. Domain has arrows, negative infinity to infinity. The range would be from negative infinity until it hits the -1. If you have any questions, please come see me.